Hello again. You've been asking how to install everything, so it seems I'm making a new video. Let's imagine we have a Jasper. The first step is, of course, to ensure it's still working. It has a retail image and it must boot into the dartboard. Okay, it works. Now we have to solve the SPI flasher, but I have solved it already, and dump the image to backup everything. We connect it to the power and use your favorite dumping tool. I use NAND Pro console version. It dumps the NAND image. It takes 5 minutes. I'll just skip it. Okay, so we have dumped this. Now we must write the image. It's the one that you may find in the pack of RGH3. It's the same. We use any tool to write the image, NAND Pro, Girane, AutoGG, anything you want. I'm writing now the 27 MHz version. They both work here, so it doesn't really matter. It takes about a minute or less. It all depends on the flasher you use. For example, Girane GR programmer is much faster, but anyways. Okay, so we have written the Zell image, and with this image Xbox doesn't start or show some strange things like red rings maybe, because we have to solder wires. As I said, there are two wires you need to solder. First one is post bit. We solder it right to the R3P71. Yes, you may use a diode here. It may improve boost sometimes. It just increases the voltage SMC gets. Black line to the post point. Never solder directly the diode to the point, because you can easily lift it. Please use another wire. Of course, you need a good flux. NC559, that's mine one. Just soldering. Solve the diode. Wire length doesn't matter. The solder quality that matters. Okay. I need some tape. Anyway. don't care much. Just a demonstration. Oh, it's double-sided tape. Even better. The other wire is a PLL one. Its tiny point is close to the CPU. Where it is? I think here it is. Yes. Here is somewhere the alternate point for this one, but I don't care. I'm soldering this right to the DB1F1. The important thing is PLL point on the CPU is 1.2 volts and on the SMC side it's 3.3 volts. So for safety reasons we may put here a resistor like on old RGH1 matrix. We use 22K resistor, that's the best value, but you can use 1K, 10K if you don't have 22K. It's the same good flux plus some wires, everything works. I'm sure you can solder much better, but that's only demonstration. Two wires, one diode, optionally, one resistor, optionally, and this must boot somehow. Okay, it boots. You have a working setup with Zell image. Now you have the CPU key, which will appear a bit later. And using this key and a backup, you prepare a freeboot image with your favorite tool. I use Girane. Load source. Enter key. Directly from the screen. Don't care much. The key is ready. Selecting glitch 2 and create the build image. Now the most difficult part for all of yours. Conversion to the RGH3 format. Now we have uptheflash.bin, which we put into the conversion folder. Here we open a command line shell. It's either PowerShell or CMD in Windows 7, doesn't matter. And we just type python.exec 223.py. We can execute it just to get some. Well, as I found, my phone can record only 10 minutes in a row. As I see, we stopped at converting the image. Yes, you just type Python exec 223 name of the RGHZL image, just for 27 MHz in this case, then the freeboot image up to flash.bin and a CPU key. And finally you put the output file name, which will be saved. And yes, it merges. It prepares a RGH3 freeboot image, which we then write to console. I will use Nance Pro as always. It takes about 5 minutes, so we can talk about Slims. Here are Corona and Trinity. On Corona, you need solder just 2 wires, diodes are not required, and resistor is really optional, because both points are 1.8 volts. PLL point is very tricky, you must scrape it with tweezers or some knife. Yes, you just scrape it, apply some flux, then attach a wire and press soldering iron to fix everything. Resistor is still recommended, for example 1K, that's a common thing. But as you see, I didn't use any and nothing died. Of course, if you don't want to risk, it's better to put it. About the Trinity, it's almost the same as Corona, similar points, but post goes right to R3, R19, you may see that on the picture, and PLL goes right to well-known DB2 G3. Resistor here is recommended because it's a 3.3 volt point. I recommend 3K resistor. As I measured, this lowers the voltage right to 1.8 as required. So that's pretty it. You just solder the wires, write the image, then convert build freeboot with script, write it to the console, and that's all. Yes, that's really simple. You need just to escape flasher. Oh no. Sorry guys. He wants to look at Xboxes. Look. That's just it. That's simple. Even you can understand. Right? Ah, never mind. Some Jaspers, as I see, are really stubborn, they don't want to boot. I hope someday I will find how to make a 5 MHz version, because on Slims I use 25 and 27 MHz, but they slow down 5 times more. That's equivalent of 5 MHz here. And damn, HANA is really unstable at this point. Well, it's about 270 blocks out of 400. I think we may stop here. Let's don't waste any time. We should see a boot. It won't boot into the dashboard because of incomplete write, but anyways. Yeah, it boots into E79, which is a result of incomplete write, but it doesn't matter, you've got the point. Dump everything, write Zell, solder to wires, with diode and resistor on FAT, as you wish. Diode is optional, it makes boot a bit stable, and resistor is just for safety. On Trinity 3K resistor, on FATs 22K resistor. You may use 1K on 10K if you don't have 22. You've got the point, yeah. And on Corona, just 2 wires, maybe with 1K resistor. That's all. You have a free boot, you have Zell, you have everything. If you have any more questions, please write them in the comments, I think. Enjoy.